Hello and welcome to another slide video from the Cornish Radio Amateur Club. This video is in the Foundation series and today we're looking at EMC or Electromagnetic Compatibility. Now if you want to do some further study on this, we have another video in the Advanced series and you may wish to have a look at that. Remember, you don't need to know everything in that video for the Foundation exam. There's just a subset of that you do need to know, and we're covering it in this one. But that's just if you want to expand your knowledge a bit further, or perhaps prepare for the intermediate or the advanced exams. So let's have a look at the syllabus for the Foundation examination. So 7A, the title is Basics of Electromagnetic Compatibility. And there are quite a few syllabus items here, which I apologise for, but let's go through them anyway. 7A1, recall that electromagnetic compatibility, EMC, is the avoidance of interference between various pieces of electronic equipment. Recall that radio transmitters can cause interference to nearby electronic and radio equipment. Recall that radio receivers can also suffer from interference from local sources. Recall that interference occurs through local radio transmissions being conveyed to the effective equipment through pickup in house wiring, TV antenna downleads, telephone wiring, etc., and, particularly at VHF, UHF, by direct pickup in the internal circuits of the affected equipment. And then we go on to say, have a look at station design for EMC. And for EMC, recall that EMC problems can be minimized by siting antennas as far away from houses as possible, as high as possible, and using balanced antennas at HF. Recall that at HF, horizontal dipoles are less likely to be a problem and that end-fed wires present significant EMC problems. Recall that information on the avoidance of interference by the correct choice and siting of antennas and suitable operating procedures is readily available from several sources. (7B2) says, recall that the more power a station runs, the more likely it is to cause interference. Recall that some types of transmission are more likely to cause interference to TV, radio and telephones than others. Recall that SSB is one of the poorest in this respect. FM, CW, which is Morse, and some of the HF data modes, such as PSK31, are much better. And then the last part looks at, or second to last part, the immunity of radio receiving and other devices and filtering techniques. Recall that the ability of any piece of electronic or radio equipment to function correctly is in the presence of strong RF signals is known as immunity. Recall that the immunity of most types of equipment can be increased by fitting suitable external chokes and filters in mains or TV antenna leads. Recall that the filters should be fitted as close to the affected device as possible. Recall that anything fitted to the mains wiring must be properly made for the purpose. Understand that homemade filters, other than ferrite rings, are potentially dangerous. Recall that information about the purchasing, making and fitting of chokes and filters is readily available from several sources. Recall that the function of the RF earth connection in an HF amateur station is to provide a ground path to minimize RF currents entering the mains earth system and causing interference to other electronic equipment. And then the final section is social issues of interference. Recall that EMC problems have the potential for causing neighbour disputes. Understand the need for diplomacy, the source of advice available, and the role of the local office of Ofcom. So that's the syllabus. Quite a few items there, none of them particularly complicated, but a bit of memory work to do for this section of the syllabus. So let's have a look. What is EMC? Well, EMC is electromagnetic compatibility, and this is a framework which defines how bits of equipment coexist without interfering with each other. So here we have a man with a hoover, and he is the source of some electrical interference. The motor in the hoover provides some sort of field coming out, inevitably, at RF. And that's just one of the things that electric motors do. And the victim in this case then is a television. And in normal circumstances, then we might find that the field radiated has no effect on the television. But then we find that when the man with the hoover moves more closely, then the field causes the television to pixelate, and this is interference. Now, we don't come across this very often because there is an EMC, an EU EMC framework and directive, and items sold, retail consumer items sold, have to be EMC compliant. So this situation should not occur. If it does occur, it's not straight away apparent whether it is the source of the victim which is at fault, because the EMC directive puts the onus on the source not to radiate too much and the victim to be impervious to a certain degree of electromagnetic radiation and still function properly. So that's the framework that we're talking about. And the imperviousness, if that's a word, of the victim to being interfered with is called immunity. And if you remember from the readout of the syllabus, that is one of the syllabus items. You need to know that items should have a degree of immunity to electromagnetic waves. And we'll see in a subsequent slide how we can improve that immunity. Well, of course, it's not always as simple as simply having a source and a victim. Sometimes things can be both at the same time. Here we have a hi-fi setup and a television setup. And the hi-fi radiates EMC. That could be, for example, the local oscillator of the FM receiver. It could be from other electronic items in the hi-fi. And indeed, the television would radiate perhaps some RF energy as well. So in this case, both items are both source and victim, but they shouldn't cause any interference to each other because they should both correspond to the EU EMC directive and should work perfectly well in close proximity. Now let's have a look at the amateur radio situation. Here we have an amateur radio, and in the top left we have a transmitting antenna. And that transmitting antenna is putting a very high level RF field down across the hi-fi. And some of that RF is managing to break into the electronics there because of its level. Now, the hi-fi may have the appropriate certification for the EU EMC directive, but the sheer level of the signal may overwhelm the protection within the equipment and cause interference. So that is an example of direct pickup, where the signal just simply blasts into the electronics directly. Now here we have a mains distribution lead connected into a house, and the hi-fi would connect, perhaps the hi-fi components would connect into that. And because the RF from the antenna is also radiating into the mains leads, this is an example of a route into the equipment, and that is mains pickup. The antenna may be sited too close to the house wiring, and then the mains may conduct the RF energy into the hi-fi components, causing a problem. Also there in green, you can see there are speaker leads. The RF energy in this case then might be directly radiated into the speaker leads. And it may not simply go into the speaker leads and then into the speakers. It may go into the speaker leads, back into the amplifier where it's amplified, and then sent out again to the speaker leads at a greater volume. And here again you can see the signal being radiated. This time we've added some phono leads, or some small signal leads, between the various components. That's carrying the low-level audio signals between tape decks perhaps and the amplifier and the tuner. Once again, signals may enter these phono leads, be amplified, and then cause interference as noise on the speakers. So when we plug in then our hi-fi components, where we have mains-borne interference, that then is carried into the hi-fi components. So let's have a look at those mechanisms. We talked about direct pickup. Direct pickup is where the antenna radiates the signal and it goes straight into the components. So if you had a hi-fi setup and you were sure that it wasn't mains-borne interference, if you disconnect the antenna into the tuner and disconnect the phono leads, for example, then if you still have problems, then that would be direct pickup. So the transmitted RF energy directly enters the affected equipment, and the solution then is to reduce the field strength, move the transmitter antenna away from the house wiring and move it high up. So if you have a vertical antenna, for example, and you move it high up, then the amount radiated off the ends, remember, is very small in a vertical antenna, and therefore you will reduce the field strength around the hi-fi. And another way of reducing the field strength is simply to reduce the transmit power. Second mechanism then that we're going to have a look at is the RF conducted from the transmitter along the mains cables. So this is when the RF enters the house wiring. It may be, for example, if you have a loft antenna and some wiring in the loft, or if the antenna runs parallel to the feed to the house, or something like that. So the RF then transfers from the antenna into the mains cables. Now you can prevent the RF leaving the shack if that's one of the problems. The shack is essentially where you've got your radio equipment, by putting suitable filters on power leads, both mains and DC. This will also help your own receivers. The third one we're going to look at is RF from antenna picked up by various wires. And in the previous example, we cited phono leads or speaker leads. Now again, you can move the antenna away from the house, or you can fit filters on affected leads. And these filters are normally ferrite rings or clip-on ferrites, which we'll look at later on. And you can have RF fed back into mains earth wires. So it's not just the positive and negative, or the live and neutral, should I say, of the mains wires which can conduct RF. RF can be fed back into the earth wires and therefore find its way into equipment. And for that you need to sort out the earthing arrangements. And we'll have a look at that in a subsequent slide. So here is a poor EMC setup. The antenna is too close to the house wiring. There's no balun fitted to the antenna. That's the balanced to unbalanced transformer. And the signal is therefore coming down towards the house wiring. There is poor quality coax. Also, that coax will radiate from its braid because there is no balun, and that means that you can get radiation from the coax braid. That will also exacerbate the effect on the house wiring. And there's no RF earth for the shack. So then, with EMC in mind, we fit a balun to the antenna. We drop our coax vertically at right angles to the antenna, and we mount the antenna as high as possible and as far from the house as possible. Now, this is not always possible depending on the house circumstances, etc. But this is, if you like, the ideal solution. The coax is buried underground. This means that if there is any radiation from the braid, it will be absorbed by the ground in which it's buried. And most importantly, there is an earth stake for RF earth only. And I would urge you to look at the Foundation Now book so that you clearly understand the difference between the shack earth, the RF earth, and the mains earth, and the different functions of the two earths. Also, you need to look at the safety section, or the safety video, which will be produced, as well as read carefully the safety section of Foundation Now, so that you understand the implications of having PME supplied to your house, protective multiple earth. If that's the case, you do need to take some special precautions with regard to the RF earth. So let's assume then that despite our best efforts, there is a television with a pixelated or complete loss of picture when you're transmitting. If the pixelation happens, of course, when you're not transmitting, then there's no point in looking for EMC solutions there. You've simply got poor reception, perhaps a poor antenna on your television or neighbour's television. But if you are transmitting and pixelation or complete loss of picture occurs, it's likely that there's a TV signal going to the television, but also an interfering signal. So we need to look at fitting a filter. So we'll fit a filter like the one shown. That will leave just on the other side a signal only from the TV. In other words, it will filter out the bandpass, the interfering signal. So you'll only have a TV signal. Now underneath the inline filter there, which is of the type you would screw perhaps to the wall or to a rafter in the loft, is another version which you can use by simply just plugging into the back of the TV an inline filter. So that is one way of perhaps solving the problem with your own TV or a neighbour's TV, fitting a bandpass filter. And the bandpass filter is designed to pass the band of the TV signals but reject other signals. And you can interpret the label on this bandpass filter. This filter is UHF, and just to recall that UHF is 300 megahertz to 3 gigahertz, but this filter then is limited to 470 to 606 megahertz, and it says there channel 21 to channel 37. And you'll need to look online to make sure that the channels that it passes are indeed the ones from your local transmitter. It also says that the rejection is greater than 30 dB and the in-band insertion loss is less than 2 dB. So there we are on the graphic at the bottom. TV channels 21 to 37 are passed, and the level is dropped by 2 dB. And that's not a huge amount, but you need to have enough signal coming in to be able to tolerate that. If you put the bandpass filter in and the signal disappears, then you're going to have to boost the signal before it gets the bandpass filter, either with a better TV antenna or perhaps with a little masthead amplifier. And it drops other signals by 30 dB. So signals outside of the range are dropped by 30 dB. Now I mentioned a masthead amplifier. That also can be the cause of a lot of problems, because a masthead amplifier, many of them are of poor quality and will amplify signals, including the amateur radio signals, and cause problems. So when you're trying to figure out what to do with these things, you've got some sources of information. First of all, you've got your local club, and you'll find people in there that have had similar problems in the past, and there may be some solutions suggested to you, or they may be able to advise you where to find expert help. The RSGB is worth a look at. They have an EMC committee. And finally, Ofcom can be brought in when there are problems that can't be solved in other ways. Let's have a look at fitting ferrite ring mains chokes. Now, a foundation book, I would strongly suggest you read that. They make the point quite clearly that this is the only safe form of fitting your own filtering, certainly at foundation level, and you shouldn't try and construct your own mains filters or interfere or modify the equipment directly internally, because that would be potentially dangerous. So this is a ferrite ring. And a ferrite ring then is a way of providing filtering on the mains. So the mains comes in, is wrapped around this ring, and the close coupling between the mains lead and the ferrite concentrates the magnetic field such that it allows the low frequency mains to go in uninterrupted, but tends to attenuate any RF. So any RF that's found its way into the mains will be attenuated by putting the ferrite ring there. And it says put it as closely as possible to the affected equipment, because that leaves only a short length, if you like, of unfiltered mains lead. And here's another picture of it. This is how to wind it. Once again, have a look in the RSGB Advanced book, and that'll give you more details. A simpler solution, or an easier one to implement anyway, is the clip-on ferrite device, such as the one pictured there, and the cable simply lies in the channel, and it's clipped and closed over the top, and that provides another solution. And you see these built in quite often to laptop power supplies and other power supplies, and they're sort of integral, if you like, to the mains lead. But these can be purchased online relatively cheaply. Let's look at the mechanisms of pickup again. Direct pickup, it blasts through. It's not really frequency dependent. It happens even with the TV antenna disconnected, and it's more problematic on VHF and UHF than HF. Conducted pickup, it comes in through the leads, and you can fit ferrites. You can also fit ferrites to signal leads, and the same logic applies, in as much as it tends to allow the low frequency audio signals through, but attenuate the RF signals that are picked up by those leads. And finally, aerial pickup. If it's being picked up on the down lead, in other words through the braid of the TV or hi-fi antenna, then a ferrite will help. But if it's if it's being picked up by the TV antenna directly, then fitting a ferrite won't help, and you'll have to look at solutions such as the one we looked at before, fitting a bandpass filter. And finally here, looking at end-fed antennas. End-fed antennas are notorious for causing strong radiation in the house. Here we have a double whammy, if you like. We have a shack upstairs, which means we have a long earth lead, and the earth lead then tends also to radiate RF before it gets down to the ground. So we have strong radiation happening back into the house. And it may be better to fit a vertical antenna if you can fit it further from the house. So there you are. You can see strong radiation both from the RF earth return and from the antenna itself. So finally then, recall that EMC problems have the potential for causing neighbour disputes. So if this happens, if interference occurs, firstly establish a cooperative approach with your neighbour. Carry out tests to see how the problem can be resolved if you can, but above all, maintain goodwill. The problem is often the inadequate immunity of the affected device, but don't assume necessarily that's the case. Older devices, before the EU directive, may not have the appropriate immunity and therefore may be easily affected, and that causes a problem. Often, it's good to obtain independent assistance, but TV repair services may have little experience of amateur radio. The RSGB has an EMC committee, which may be able to assist by providing advice. And the local amateur radio club may be able to suggest somebody that's suitably qualified, or indeed suggest possible remedies. And if the problem is intractable, then in difficult cases it may become necessary to seek the assistance of the local Ofcom office. Once again, have a look at the and read carefully the section on the neighbours, which is on page 27 of Foundation. I've seen questions relating to this and the approach that you need to be able to take. So I think a careful read of the text in advance will serve you well for the examination. So we'll whip through the syllabus again quickly to make sure we've covered everything. Recall that electromagnetic compatibility is the avoidance of interference between various pieces of electronic equipment. We've talked about the dual responsibility, the responsibility of equipment not to radiate too much, and also to be able to tolerate some incident radiation. Recall that radio transmitters can cause interference to nearby electronic and radio equipment. So radio transmitters radiate not just a little bit, but a lot. And so they can overwhelm even equipment that is suitably EMC tolerant. So recall that radio receivers can also suffer from interference from local sources. If you have a noisy electric motor, it may well, or a thermostat, or some solar panels and a regulator nearby, they can be the source rather than your transmitter. So one of the things that Ofcom will probably ask you to do if you're involved in some sort of incident is to keep a log so that they can correlate the time when the interference is experienced and the time when you're transmitting. And if they don't correlate, then they'll be looking for something else as the interference source. Recall that interference occurs through local radio transmissions being conveyed to the affected equipment through pickup in house wiring, TV antenna downleads, telephone wiring, etc., and particularly at UHF by direct pickup in the internal circuits of the affected equipment. And we looked at the 4 mechanisms for pickup in an earlier slide. Station design for EMC. Recall that EMC problems can be minimized by siting antennas as far away from houses as possible, as high as possible, and using balanced antennas at HF. This is one point perhaps that we did not cover, that balanced antennas provide less EMC, if you like, than unbalanced antennas. But remember that if you are using a coax feeder to a balanced antenna, you must use a balun. Recall that at HF, horizontal dipoles are less likely to be a problem, and that end-fed wires present significant EMC problems. We had a slide looking at that. Recall that information on the avoidance of interference by the correct choice and siting of antennas and suitable operating procedures is readily available from several sources. We talked about the club, we talked about the RSGB, and Ofcom itself. Recall that the more power a station runs, the more likely it is to cause interference. I suppose this is self-evident. If you had a 1 watt handheld, you'd be very surprised if you caused interference to your neighbour's television. If you had a 400 watt, if you had an advanced license, this is a full license, I beg your pardon. If you had a full license and you had a 400 watt linear with SSB, then the likelihood of causing interference is far greater. Recall that some types of transmission are more likely to cause interference to TV, radio, and telephone than others. And recall that SSB is one of the poorest in this respect. FM, CW, which is Morse, and some of the HF data modes are much better. Now, this is not explained at foundation level, but is explained later on, I think, at intermediate and advanced levels. So you can certainly find information about this by looking at those videos or online. So it's the envelope modulations which are most likely to cause problems. And of course SSB is commonly used both at HF and VHF. So if you are using SSB and you create a problem and you don't at FM, then don't assume that the problem is not being caused by you. SSB is problematic in this respect. So immunity of radio receiving and other devices and filtering techniques. Recall that the ability of any piece of electronic or radio equipment to function correctly in the presence of strong RF signals is known as immunity. We talked about this. We talked about the inherent immunity of certified devices, and then being able to improve the immunity by putting things like ferrite rings on input leads and by fitting bandpass filters to antenna leads, things like that. Recall that the immunity of most types of equipment can be increased by fitting suitable external chokes and filters in mains or TV antenna leads. Just covered that. Recall that the filters should be fitted as close to the effective device as possible. You don't want to leave unprotected lengths of lead before the device, otherwise they will act as pickups. Recall that anything fitted to the mains wiring must be properly made for the purpose. So here they're saying don't go dabbling around opening up covers and fitting filters internally yourself because, or designing or building them yourself because that is dangerous. And other than ferrite rings, homemade filters are potentially dangerous. Recall that information about the purchasing, making and fitting of chokes and filters is readily available from several sources. Recall that the function of the RF earth connection in an HF amateur station is to provide a path to ground to minimize RF currents entering the mains earth system and causing interference to other electronic equipment. And I would just caveat that by saying make sure you have a look at the safety section of foundation in respect to PME earths and take suitable precautions. The social issues of interference. Recall that EMC problems have the potential for causing neighbour disputes. Understand the need for diplomacy, the sources of advice available, and the role of the local office of Ofcom. And you get quite a few questions around this in the foundation exam saying, for example, your neighbour has an old television set, and it's determined that when you transmit, the picture becomes unviewable. What should you do? A, B, C, or D? And so you need to read quite carefully the section on page 27 of Foundation to make sure that you make the appropriate choices for those types of questions. So I think that sums up EMC. Thank you very much indeed for listening. Next we will be looking at syllabus section 8, operating practices and procedures.